Next few minutes we're going to talk about backstops or holdbacks, or one-way clutches to keep the conveyor from running backwards. If we go back to Belt Analyst, we go to the Pulley tab, scroll down to the bottom, you'll see that there is a line item to tell you whether a backstop is required or not. That is a static analysis methodology. Doesn't give you a lot of information, but does tell you whether one's required or not. When we come over to dynamic analysis, you'll see there is a tab here for backstops. But before we do that, we're going to click the auto tune button. It is good practice to do this periodically, just to make sure that the tuning parameters are up to date and the damping multipliers are properly set. And this is the first time we've run this particular example in dynamics, so we're going to go ahead and do the auto tune. We click on the holdback tab, and you see there's one drive pulley. A backstop has to be at the drive pulley, but it's unchecked. You see that box is unchecked in this case, and if we do the analysis, if we run the analysis, you can see that the thing never comes to a stop. When it comes to zero, it just turns around and goes backwards, negative velocity, which means we don't have a backstop, and we need one. So we click the backstop and say, okay, put a backstop on pulley number one, drive number one. We rerun it, and you see now the belt does come to a stop. And if we run the animation, you'll see that when the belt gets to zero speed, it doesn't run backwards, which is exactly what we want. If we go look at the torque here now, you can see the torque on that pulley. That's the torque across the pulley. You see it comes to a stop here at about 8 seconds, and you can see there at 8 seconds the torque comes back up, and that is the actual torque on the backstop across the pulley when the belt comes to a stop. Many times though, our backstops are not necessarily on drive pulleys, and so what happens if we want to put the backstop on the discharge pulley in this example? Well, first thing we have to do is define the head pulley as a drive pulley. So I'm going to insert a drive at this point, and I'm going to move that drive right to the head pulley, so it shows the head being a drive pulley. And I'll go over to the drive tabs now. Although I want it to be a drive pulley so I can put the backstop there, I don't want it to have a motor, so I put 0 power in for the motor. And you can see I have 0 power, 0 braking, nothing there, just the definition as a drive pulley. That's all. That just gives us a point to put our backstop on when we get over to the dynamics program. So we come over to the dynamics, and I'm actually going to refresh the data from Belt Analyst, make sure that it's properly recognized that I added a drive pulley. Now I have 2 drive pulleys. I'm going to pick the first one, which is the head discharge pulley, and put the backstop there and run the simulation again. And when we run the animation, you'll see when it comes to a stop, you'll see actually the torque being added to a second pulley, which is the discharge pulley, not the drive pulley. In order to look at the torque in this particular example, my default torque is only on my actual drive pulley, so I'm going to go up here to Format and Plot Points, and I'm going to take the description for the head pulley now, which actually is my backstop location. I'm going to start that description with DR for drive, and anything with DR in the description then will show up on this torque plot. Now you'll see that the red line is the motor, where we shut the motor off, and the blue line is the torque on the head drive. And you can see as soon as the belt comes to a stop, the torque goes up on the backstop.